Today's lesson is about subtracting integers. In this lesson today, you're going to learn how to subtract integers using chips like we did with the adding integers lesson, and you're also going to learn how to use the mathematical procedures to subtract to solve integer problems. So let's begin. One key concept that you need to know is that subtracting a number is the same thing as adding its opposite. So what I mean by that is that we all know that 5 minus 4 is 1. But if I change that around and I say 5 plus negative 4, the answer to that problem is also 1. So what that shows is that subtracting 4 is the same thing as adding negative 4. And that's how we're going to solve our subtracting integer problems. We're going to turn them into addition problems and then use the same rules that we learned in the last lesson to solve the problems. Okay? So here's how we do that. We have to take the subtraction sign in the middle of the problem and turn it into an addition sign. And then the second number in the problem becomes its opposite. So think about this example I gave before. 5 minus 4 is the same thing as 5 plus negative 4. They both equal 1. Let's work on an example here. Negative 6 minus 7. Now, based on what I just showed you, the first number, negative 6, will stay the same. And you can see that it does throughout the problem. The sign in the middle, though, the subtraction sign, has to change into an addition problem. And it tells you that in part A here. So we change the subtraction sign to an addition problem. And then the second number becomes its opposite. The number here is 7. So we're going to change 7 into its opposite, which is negative 7. And now we have an addition problem that we've learned how to solve already. So same sign means find the sum. 6 plus 7 is 13. Both signs are negative, so we're going to keep the negative sign. So the answer to this problem is negative 13. Example number 2, let's use the same procedures. One quick phrase you might be able to use to help you remember these procedures is keep, change, change. Keep the first thing the same, the first number. Change the sign in the middle from subtraction to addition. And then change the number that comes last or second in the problem to its opposite. So let's do that with this. Keep negative 11 as negative 11. Change the subtraction sign to an addition sign. And then down here in part B, change negative 17 into positive 17. So the problem we're left with is negative 11 plus 17. Based on our addition rules that we have already learned, different signs means find the difference. So 17 minus 11 is 6. And then since the larger number has an absolute value that is positive, or since the larger absolute value is a positive number, we're going to change the solution to positive 6. So negative 11 plus 17 is positive 6. Try practicing the 6 problems here. Pause your video. When you feel like you have the answers, you can play again and see how you did. Here are the answers to the practice problems. What you can see is that in every single problem, I use that keep, change, change rule. So I kept the first number the same in every single problem. I changed every single subtraction sign in the problems to addition signs. And I made every second number its opposite. So negative 3, positive 3, negative 10, positive 10, negative 5, positive 5, 3, negative 3, negative 10, positive 10, 5, negative 5. And then I apply my adding rules. Remember your adding rules. Different sign means find the difference, like in question 1 and question 5. Same sign means find the sum. So like questions 2, 3, 6, and 4. Okay? So you have your answers. See your teacher if you need some help with these or to clarify. We're going to move on now and figure out how to solve subtracting problems using chips. The chips are just like the addition ones. You have different colors, and each one represents either positive 1 or negative 1. So what we can do here is do subtraction problems. Subtract means to take away, so we're going to take away chips from our set. Sometimes we don't have enough chips to take away, though, so we have to add in 0 pairs, that same thing we used before, to help us get enough chips to take away. So that may sound confusing, but I'm going to show you an example that hopefully helps you make sense. Here's an example, negative 9 minus negative 7. Let's start by using negative 9 chips. So we have 9 chips with negative signs. Okay, we're going to set those out, and we're going to subtract 7 of the negative chips away by taking away 7 of them. So since we have 7 negative chips to take away, we can just take these 7 chips. Let me move a few over here. That looks like 5 of them. Here's 6, and here's 7. I'm going to move over 7 chips. I'm left with 2 negative chips. So since 2 negative chips are left, that's the answer to the problem. If we check by using our math, what we could see is that negative 9 minus negative 7 would turn into negative 9 plus positive 7, which would also, if you do the math, give you an answer of negative 2. So our chip method worked out for example A. Let's do example B. Now it's negative 9 minus 4. So we start by laying down our 9 negative chips. And what we have to do here is take away 4 positive ones. Here's the problem. I don't see 4 positive ones. So what do we have to do? We have to add in 0 pairs until we have 4 positive chips. I'm allowed to add in 0 pairs because they don't have value. So I can do this, and this whole picture still means negative 9 right now. Even though there's positive and negative chips over there, the ones in the orange box have no value because each one cancels out the other opposite one. So the picture still shows negative 9. But now I have enough chips where I can remove the 4 positive ones. So if I remove the 4 positive chips from the picture, what am I left with? I'm left with 13 negative chips. It just so happens that negative 13 is the answer to the problem. So as you can see, I moved in 0 pairs until I had enough chips to take away, and then I took those chips away. It doesn't tell me to take away negative chips in this problem. It tells me to take away positive ones. That's why I had to add in the 0 pairs like I did right here, so I'd be able to take away 4 positives. Okay, but again, remember, the net value of that orange box is 0 right now. So that picture still shows negative 9. So again, I took them away. I'm left with 13 negative ones. There's my answer to the problem. Hopefully this video was helpful. You can rewind if you need to. Use this for your notes and homework like you usually do when you're preparing for quizzes. And I'll see you next time.